Okay, today's the day you've been waiting for to be able to put together both the translation and the scale change. So we're going to put 4-7 and 4-8 together, and we're going to see what happens when we do a composite of a scale change and a translation. And so this says if you put any trigonometric function into standardized form, you'll be able to quickly know the A, the B, the H, and the K. Remember, the A and the B are from the scale change, and the H and the K are from the translation. You can use those values to find the amplitude, the period, the phase shift, the vertical shift of a function, and the domain and the range. Okay, so to do this lesson, you need to grab about 3 things. You're going to need these video notes, you're going to need a blank note card, and you're going to need your graphing calculator for a problem that we'll do on the back of it. Okay, the information that goes on the note card is right here, in between these 2 red lines that I'm drawing on here. And you can call this note card 4-9, the Graph Standardization Theorem. It says that when you put a sine or cosine function into the form y minus k over b equals sine x minus h over a, this could also be cosine, okay, sine or cosine, then right away the amplitude we know to be the absolute value of b, and the period is 2 pi times the absolute value of a. That is coming from lesson 4-7. And we also know the phase shift is h, and the vertical shift is k, and that's coming from the translation from lesson 4-8. The only thing we would do different for tangent functions, which we need to make a note of, would be that their amplitude would be none, or you could write undefined, because they don't have a maximum and then a minimum and then a maximum and then a minimum. Remember the tangent function? It looks like the cubic, it kind of keeps going on forever in both directions. And the period of that function is only pi times the absolute value of a. So those are the 2 things that will make notes differently for the tangent function than the sine or the cosine function. If you need to take a minute to pause this and write everything down, then pause the video and make sure you get that all written on your note card. Okay, now we're going to use that information then to take a function like number 1, which says y equals 5 times the cosine of 4x plus 4 pi plus 10, and we're going to figure out all of these things over here, the domain and the range, the amplitude, the period, the phase shift, and the vertical shift. In order to do that, we need to find out the 4 important things, A, B, H, and K. That's what we need to find out. So it doesn't say first find A, B, H, and K, and then find all this other stuff. I'm just telling you that's what you're going to do every time, and you won't be able to find the other things necessarily unless you find the A, B, H, and K. Alright, so the first thing that you want to do is you want to take this function and you want to get this all by itself. So you need to get rid of the 10 and the 5. You're going to subtract the 10, and then divide by 5. So you're going to wind up with y minus 10 over 5 is equal to the cosine of 4x plus 4y, or 4 pi, sorry, 4 pi. Okay, now, very, very important that you remember that you can only have 1x here and 1y here. Just like when we were doing those transformations, scale changes and translations back in chapter 3, and I made you get a 1 right there, well, that's what you have to do here too. So this problem has a problem in it because we have a 4 right here. So let me do a little what we call sidebar over here. And the sidebar looks like this. You have 4x plus 4 pi, and you want this to go to 1x. So you need to factor a 4 out of there, which means you need to pull that to the front and literally divide each term by 4. If you do that, this will say x plus pi. So you will then have y minus 10 over 5 equals the cosine of 4 times x plus, oops, can I get that? X plus 5. And then multiplying by 4 is like dividing by 1/4. So we're going to write it this way. And now we have it in our form where we have x, or y minus, this would be like y minus k over b cosine x minus h over a. And now we can fill in these amounts. A is 1/4, B is 5, H, be careful on this because they're opposites, plus pi means we're going pi to the left, and over here, minus 10, that's y minus k, means we're going up 10. Alright, we're going up 10. Alright, once we get that figured out, let's talk about the domain of cosine function. Unless restricted, the domain of all cosine functions should be all real numbers. The range of this function. Now the range is kind of tricky because we have to combine the the b and the k together. If you have an amplitude of 5, that means your graph will go up to 5 and down to -5, won't it? So if this is the x-axis, this height right here would be 5, and down here would be -5. So we're going to go from a low of -5 to a high of 5, but then this k equals 10 tells us we're going to bump the whole thing up 10. So we want to add 10 onto each of these. So the range is going to go from 5 to 15 with brackets around it. Okay, next is the amplitude. Amplitude is the absolute value of b. The absolute value of 5 would give us 5. The period is 2 pi times the absolute value of a. So the period in this case would be pi over 2, wouldn't it? And the phase shift is strictly h, and the vertical shift is strictly k. Alright, so let's see if we can do number 2. On number 2, the first two numbers I see that are misplaced that need to be changed are the -5 and the -4. You would add the 5 over and divide by the -4. Okay, now you notice there's a 2 here and we can only have a 1. So we're going to come over here and we're going to say we have 2x plus pi, and we only want 1x. So we have to divide by 2 and divide by 2. So if you went back and redistributed that, you'd be right back to 2x plus pi, wouldn't you? We're not changing the value of it, we're just changing the way it looks. Alright, so our numerator is going to be x plus pi over 2. Multiplying by 2 is like dividing by 1/2. So we need to find A, B, H, and K. Alright, A is a half, B is -4, H, this says pi plus, or x plus pi over 2. That means we would go pi over 2 to the left. And then for K, we have a y, or we have a divided by, let's see, what's K? K is x minus h here, or y minus k, y minus k, that'll give you a -5 on it. Okay, we want to find all these things again. The domain of a sine function, going to be all real numbers. The range of it, we're going to use the b and the k together. This means we're going to go from a low of -4 to a high of +4, and then we're going to move the graph, move the graph down 5. So we're going to subtract 5 from that and from that. So this is going to go from -4 to +4, subtracting 5. That would give us going from -1 to -9, right? So that means we're going to go from -9 to -1. Part C says we want to do the amplitude. The amplitude is the absolute value of B, so the amplitude is 4, isn't it? Next is the period. It's 2 pi times the absolute value of A. That would just give us 1 pi. Next is the phase shift. The phase shift, you might recall, is the h amount. So that's minus pi over 2. And the vertical shift is k, and that is -5. Alright, so once you get your A, B, H, and K figured out, it's not too hard to find out all the parts they want for us over here. Okay, I thought I'd better show you a tangent one because sometimes those can be kind of tricky. 2 changes on it will come right here when we study amplitude and period. There'll be 2 big changes right here. But for now, we just want to dismantle it like we've done all the others. Y minus 4 divided by 2, the tangent of x plus pi over 6. Okay, you're going to notice that the coefficient of x is already 1, so it's like having this all over 1, isn't it? Alright, so let's go ahead and write down A, B, H, and K. From the formula, A would be 1, b would be 2, h would be negative pi over 6, right? And k would be 4. All right? This is going to be hard too. The domain is going to be different. You know that right now the domain is based off of all real numbers except where the asymptotes go. Well, we're going to shift all of the asymptotes. I'll write that down. Are shifted pi over 6 to the left. Pi over 6 to the left. Okay? So, if you go to your yellow note card and you look at the original asymptotes, they're going to be at negative 3/2 pi, negative 1/2 pi, 1/2 pi, 3/2 pi, and so on. Okay? Now, that means this is negative 9/6 pi, this is negative 3/6 pi, oops, 3/6 pi, this would be 3/6 pi, this would be 9/6 pi, and so on, if I want to look at them as 6. If I take my function here and I subtract 1/6 of a pi from each of these, I'll be down to negative 10/6 pi, negative 4/6 pi, 2/6 pi, 8/6 pi, and so on. So the pattern of these would be negative 5/3 pi, negative 2/3 pi, positive 2/3 pi, no, 1/6 would be 1/3, 2/6 would be 1/3 pi, and 4/3 pi, like that. So when you're writing this, there's a couple of different ways you could do it. You could say all reals except, and then just name what's on your note card. On your yellow note card, it's odd multiples of k times pi over 2, okay? And then I could say minus 1/6 pi, okay? So I don't want to take it 1/6 to the left. Now there is a pattern to these. These are all starting at 1/3 pi. They're all a pi apart from each other, aren't they? Each one is adding on a pi each time. So you could say all reals except, okay, that would be pi over 3, 1/3 pi, right? Plus, add on a pi. Pi times n, where n equals some integer. And that'll get you the pattern for all the asymptotes. They're all spaced evenly a pi apart. The range of this function is going to be from negative infinity to infinity, because remember the tangent function, the parent function, looks like this. Has arrows on both ends, doesn't it? Okay, amplitude, we are just going to write none. I know you think you want to get a numeric value for that, but amplitude, the concept of it doesn't exist. Okay? Next step would be the period. Remember, it's just pi times the absolute value of a. So it's just going to be pi, isn't it? And then the phase shift. This says x plus 1/6 pi, which means we're going to go 1/6 of a pi to the left. And the vertical shift says y minus 4, which means we're going to go up 4. Up 4. Okay, we'll get a lot of good practice on those next time when you come to class. So if you didn't understand those, go over them again. All right, now they want to know what composite, the composite of what scale change and translation would map y equals cosine x onto this graph right here. All right, well, what they really want us to do is write out the scale change and the translation. So in order to do that, I need to know A, B, H, and K, don't I? A, B, H, and K. That's the key to everything today. A, B, H, and K. We're going to rewrite this by saying y plus 10 divided by 3 equals the cosine of x plus pi. And then multiplying by 4 is like dividing by 1/4, isn't it? So that means A is 1/4. b is 3, h is the opposite of pi, and k is -10. Alright, if they want us to write this translation and the scale rule, let's see, did it say a single translation? A composite. A composite. Okay, the scale change by itself would be 1/4 x, 3y. The translation by itself is going to be x plus pi, right? And, no, is that a plus sign? It's going to be x minus pi, comma, y minus 10. Okay, and we want to put that all together. So we want to do an S following T thing. Okay, I would put these two parts together, and those two parts would tell me that I would have 1/4 x, right? And then minus pi. And then for the translation part, I'm going to have, for the y coordinate, I'm going to have y. So this is just a I'm going to have 3y, because I have a b there, by, and then I'm going to say minus 10, by minus 10. So this is ax minus h, by minus k. Actually, that's plus h and that's plus k, isn't it? Okay, let me make sure I got that right. Okay, so I just want to make sure everybody knows what we're doing with this one more time. We're doing the scale change following the translation, or you could even do them vice versa, but they will wind up being ax plus h, by plus k. Alright? And the rule will be the rule, so these numbers right here will be the exact numbers that you will put back in the rule when you put them in here. Okay, we'll try one more of those. The composite of what scale change and translation maps y equals sine x, so we're going to use a different parent function this time, onto this. Alright, so we don't have any number out here to add or subtract onto the other side, so we're going to write this as just y divided by 2 is equal to the sine of, and if you're getting good at these, we'll do a little sidebar over here, we have 3x plus pi, which means we're factoring out a 3, which means we're dividing each term by 3 to make this be x plus pi over 3. So the numerator will be x plus pi over 3. Multiplying by 3 is like dividing by 1/3. So we write down a, b, h, and k. A is 1/3. B is 2. H is the opposite of what you think it's going to be. It's in the grouping symbol. So it's minus pi over 3. And there is no k value, so we'll just put 0 for that. Alright? So when you put your scale change and translation together in this, S following T. Oh, you know what else I didn't do on this one? I didn't put an x comma y right there. I'm going to write this correctly here. X comma y. Okay, it's going to be ax, so 1/3 x, minus pi over 3, because that's that plus h, comma, in this case we'll just have a 2y. Alright? So this is the exact correct form that you need to be doing. I didn't get the x comma y on that one right there. Okay. Alright. We'll have some more of those that we'll practice on in class as well. Okay, now we're back to the Ferris wheel, and I want to reset my window so that I can put my graphing calculator on here so that you could see this, because we're going to have to graph this on our graphing calculator. It says, in the Ferris wheel pictured at the right, Darlene is in the seat labeled by point D. So she's in the seat right over here, labeled at point D. When the ride starts at time t equals 0, and it takes 10 seconds for Darlene to reach the top of the wheel. So the top of the wheel would be right here. So when we go this distance to get to the top of the wheel, that distance in red is going to take 10 seconds for that to happen. Okay? She will be 45 feet off the ground when that happens. 45 feet off the ground. Okay, if the wheel turns at a uniform speed of 2 revolutions per minute, so 2 revolutions per minute, it can be shown by this equation down here. So they made an equation, and they're saying that we have 20 times the cosine of pi over 15 times the quantity t minus 10, and then a plus 25. So normally we'd see the plus 25 on the back end showing that it got pushed up 25, and it's saying that the cosine is being multiplied by 20 here, which means it's going to go up to 20 and down to negative 20 and up to 20 and down to negative 20. But then when you add on this 25, it'd make it go from a low of 5 up to 45. Okay? So it gives Darlene's height d, that's the height, the d, in feet above the ground as a function of time. So, for instance, at 10 seconds, when we put 10 in here, we should be at the top of the circle. We should get 45 for that. Okay? It says after the wheel starts to rotate. Assuming the ride will continue for at least 2 minutes, that's where we get this 120, because that's 120 seconds. We want to find all the times where Darlene is closest to the ground. Closest to the ground. Okay? So really, the best way of doing that is to probably analyze this function right here. And by analyzing it, I mean putting it in its stacked fraction form. So we would have d minus 25 divided by 20, right, times the cosine of, we'll leave this one t minus 10 on the top, and then multiplying by pi over 15 is like dividing by 15 over pi, like this. Okay? So we could then find the a, the b, the h, and the k. So in our case, a is a weird amount, it's 15 over pi. B is 20, h is 10, and k is 25. Alright? And we really want to find that stuff so we can figure out what to do or how to make this make sense in our mind so we can figure out what to do to get a good window for it mostly. Okay? If this is pi over 15, then if you want to find the period of the graph, the period of the graph is 2 pi times the absolute value of a, isn't it? So that would be 2 pi times 15 over pi, wouldn't it? That's going to cancel out, and you're going to wind up with 30. Remember, we're talking about this being in terms of time in seconds, so that means that it would take 30 seconds to go all the way around. So if she's starting at this position right here, and we went all the way around once, it would take 30 seconds to get back to that position. Okay, so that's like 30 seconds is the period. Okay, and if we look at the b and the k together, that means we're going to go from a low of negative 20 to a high of 20. So as this thing is going up and down and up and down, but then we're going to bump it up 25. So we're going to go plus 25 plus 25. So that means that our range on this function would go from a low of 5 to a high of 45. And that makes sense because the wheel's not going to hit the ground. You have that little ramp you walk up to get on the Ferris wheel, and so that means it's a little bit off the ground. It's not going to come down the bucket, it's just going to hit the ground. Okay, so let's think what a good window for this graph would be. All right, in terms of time, we want to start at 0 seconds, and we want to go to 120 seconds, right? And the x scale on that, then let's go in increments of 30 seconds, because remember that was one trip around or one whole period of the graph. And then to make this work for the y, we'll want to go y min and y max and y scale. Okay, I want to get 5 to 45 on there, but I want room below it and I want room above it. What if we went negative 10 to, let's say, 60, and we went, 60, and let's say we go by 10. How would that be? Okay? So the first thing I want you to do is to type that function in your calculator. Move my cursor out of the way. You don't need to put a lot of extra parentheses in it. It needs to say 25 plus 20 times the cosine of 1/15 times x minus, or not 1/15, pi over 15 times x minus 10. So there does need to be two sets of parentheses in this. We want one around the whole cosine function and one around the x minus 10 part. Once you get that typed in, let's go to the window and let's use this window we set up here. So let's take time to go from 0 to 120 seconds in increments of 30. And let's go from negative 10 up to 60. We have to adjust that a little bit. And we'll go by 10. We'll see. Okay, we do need to be in the mode of radians for this, because remember we were starting with a values with the pi's in them, and we've got a pi value in here, a pi over 15, so we do need to be in the mode for radians. Okay, I'm going to switch graphs. Oh, that's not too bad. This is a picture of Darlene's ride around the Ferris wheel. Alright, she is starting here, and then she goes to the top of the wheel after so many seconds. In fact, it was supposed to be 10 seconds. So if I trace 10, sure enough, at 10 seconds, she's at the highest part of the wheel. And then she's come down to the bottom of the wheel, back to the top, the bottom, the top, the bottom, and so on. We want to know all the times she's at the lowest point on the wheel. Alright, well, let's see if we can find that lowest point on the wheel. We'll trace that as a minimum, won't we? Okay, so minimum. And it looks like it occurs when x is equal to 25. When y is an exact value and x has all this rounding error on here, that's 25 seconds, isn't it? Okay, so if I make a little picture of what's going on here, this is 25 seconds right now. Now, we could either trace the next one over, because there's 3 places where she's at the lowest part of the wheel, or we could use the fact that we know the period of the function is 30 seconds. The next one should occur 30 seconds from the first one. So if we type in 55, sure enough, we're at the bottom of the wheel again. So this would be 55 seconds. If I do another one where I say 55 plus another 30, that's going to happen at 85 seconds, isn't it? Okay, so we're going to say that she will be the closest to the ground at 25 seconds, 55 seconds, and 85 seconds. Oh, wait a minute. Was there oh, there's another one. There's just not another one on my picture, is there? Okay, I need to do one more down here. Okay, add another 30 under that. That'd be 115 and 115 seconds. All right. We'll be doing a lot more problems in class and revisiting the Ferris wheel when we get to class as well, so you might want to just keep that in your graphing calculator, and you can do some modifications on it to do some of the other problems. If you have any trouble with these, please see me.